I'm Anil Kumar. Welcome to my series on application of integration. We'll have many questions based on displacement, velocity, and acceleration in this set of videos. We'll begin with the objective type questions and introduce in between thinking and application questions, followed by some test papers. Here we'll share with you two questions, multiple choice. Question number 1. The instantaneous velocity of an object is v of t equals to 8t minus 5 centimeters per second, where t is greater than or equal to 0. What is the displacement in the first 5 seconds? 4 options are given to you. Second question is, the instantaneous velocity of an object is t minus 3 whole cube centimeters per second, where t is greater than 0. Find the displacement s at t equals to 0 if at t equals to 2, s equals to 4. 4 options are again given to you. You can pause the video, answer these questions, and then look into my solution. So to begin with, we are interested in finding displacement, right? So displacement s of t is integral of the velocity, right? Is the integral of velocity. We are given the velocity function, so let's integrate it. It is 8t minus 5 dt, and the integral of this will be 8 t square over 2 minus 5t plus a constant c. Now we need to find the displacement in the first 5 seconds. Now when we say first 5 seconds and we are saying t is greater than or equal to 0, that means we want this displacement from 0 to 5, correct? So one thing is important to understand here, that this graph is of displacement a parabola, right? Do you see that part is a parabola? So let me write this function s of t as equal to 4t square minus 5t plus c. So that is our expression. Now we're talking about displacement. That means from 0 to 5. Now it should have been the distance anyway. So what we'll do here is that we'll find what is s of 5, and from that we'll take away s of 0, right? That is what we are going to do. So we'll substitute the value 5 here. So we get 4 times 5 square minus 5 times 5 minus c, and from this value we'll take away when t is 0. So when t is 0, we are left with minus c, right? So well, it's good to write plus c, okay? So we are left with c. As you can see here, c and c will cancel, right? So what remains is 4 times 5 is 5 square is 25 times 4 is 100, right? Minus 5 times 5 is 25, right? And that c minus c is 0. So we're left with a value which is 75. So the answer is 75 centimeters, correct? So that is how we are going to find the solution of this one. Now the second, so displacement is change in position, right? So that is why this is correct answer. Question number 2. The instantaneous velocity of an object is t minus 1 whole cube centimeters per second, where t is greater than or equal to 0. Find the displacement s at t equals to 0 if at t equals to 2, s is given to us as 4. So here we are given the initial condition. We can find the constant. In the previous case, you can realize that there was no need to find constant. We were trying to find difference, and so it cancelled, right? Okay. Now, so again, displacement is integral of the velocity, right? So which is integral of the function which is t minus 1 whole cube dt. And applying the power rule, we get t minus 1 to the power of 4 times 1/4, right? Plus a constant c. Now we are given the initial condition that at t equals to 2, s equals to 4, right? So we know that s of 2 is actually equal to 4, right? So we'll substitute 2 here. So we have 1/4 of 2 here, 2 minus 1 to the power of 4 plus c. So we can find the value of c from here. So this is 2 minus 1 is 1, 1 to the power of 4 is 4, right? So multiplying this, what do we get? So, okay, so we get 1 over 4 here. So I'll actually take it to this side. So 1 over 4 take away from 4 should be the value of c, right? This is 1, correct? So that gives you 3.75, you can say. Since the answers are in numbers, 4 minus quarter will be 3.75. Let me write like this. So c is 3.75. Now we want to find the value at t equals to 0. Okay, so let me use the right side of the page to find the answer, right? So we'll find it here. So c is for us 3.75. So we can say s of t is now equal to this expression 1 over 4 t minus 1 to the power of 4 plus 3.75, right? Okay. So if I substitute 0 here, I get 1/4 to the power of 0 minus 1 to the power of 4 plus 3.75. So that is 1/4, this is 1, right, which is 0.25, which is equal to 4, right? So quarter plus 3/4, 3.75 gives us 4. So the option D is the correct option. Do you see? So by integrating the velocity function, we can find the displacement and we can solve these questions. So I hope this concept is absolutely clear. Now let's take question number 3 and 4. Question number 3. The instantaneous acceleration of an object is a of t equals to minus 5 centimeters per second square, where t is greater than or equal to 0. What is the change in velocity from t equals to 2 seconds to t equals to 5 seconds? Question number 4. A particle is moving along the x-axis so that at time t in seconds, its velocity v of t in centimeters per second is given by v of t equals to 2t square minus 3t plus 2, where t is greater than or equal to 0. Its initial position is 5 centimeters to the left of origin. So that means at t equals to 0, the position is s of t at 0 is minus 5. What is its position after 6 seconds? The choices are given to you. You can pause the video, answer the question, and then look into my suggestions. Okay, so the very first one here, we are given the acceleration a of t, which is a constant minus 5, right? We want to find the change of velocity, right? So change of velocity is integral of acceleration. So velocity basically is integral of acceleration, correct? So in our case it is minus 5, so we'll do integral of minus 5 dt, and so we get the velocity as equal to minus 5t plus c. Now constant c we can find from the given position. So it says the instantaneous acceleration is this much. What is the change in velocity at these two times? So when they want change in velocity, we don't need to find c, right? And even otherwise you can't. Okay, so now let's find the change in velocity from t2 to t5. That means v5 minus v2 is what we're looking for, correct? So substituting those values here, we get minus 5 times 5, right? That c will cancel. You may write plus c, okay? Take away. Writing 2 here in this equation, we get minus 5 times 2 plus c. So when you calculate this, minus 5 times minus 5 is minus 25. C and C cancel, and this minus and minus becomes plus 10. So the change is minus 15, right? So that is the change. So option A is the right option, correct? So that is how we are going to find the answer. Question number 4. A particle is moving along the x-axis so that at time t in seconds, its velocity v of t in centimeters per second is given by, let's write down. So velocity is given to us as 2t square minus 3t plus 2, where t is greater than or equal to 0. Its initial position is, so we are also given at t equals to 0, is s is equals to minus 5, right? Left of origin. What is the position after 6 seconds? Okay, so we need to find at t equals to 6 what is s, right? That is what we need to figure out. Okay, so s is the integral of this. So we can find displacement by doing integral of the velocity function. So let's integrate this with respect to time, correct? So we'll integrate this with respect to time. What do we get? So 2 times t to the power of 3 over 3 minus 3t squared over 2 plus 2t, right? That's what we get, plus a constant c. Now to find the value of constant c, we can use what is given to us. So at t equals to 0, s is minus 5. So if I write 0 here, so s of 0 is equal to minus 5, right? So minus 5 is the value of, this is all 0, is the value of c. So you can get the expression for s of t, right? So s of t is equal to 2 by 3t cubed minus 3 by 2t squared plus 2t minus 5. So that is the expression for displacement. Now what is the position after 6 seconds? So we'll write 6 here and calculate, right? So s of 6 is basically equal to 2 over 3, 6 cube, right? So we have 6 cube minus 3 over 2, 6 square, right? Plus 2 times 6 minus 5, correct? So if the calculator is allowed, you can definitely use calculator and figure this out, right? So otherwise, what do we have? So you can say it is 6 square is 36 times 2, 72, and 3 goes 2 times. So 72 and 2 is 144, correct? So we get 144 here minus 6 square is 36, half of 36 is 18, and we have to multiply 18 by 3, right? So we have to multiply 18 by 3. 3 times 8 is 24, 2, so we get 54 here. Plus 12 minus 5, right? That's what you get. So it's a big number. So we have to take away 12 from these numbers, okay? So it is, let's add 12 first. 6, 5, 1, take away 59. Okay, so when you take away from 16, you get 7, and then you get 9. So 97 is the right answer, correct? So 97 centimeters is the position at 6 seconds. So I hope you understand how, with the help of integration, we found in the first case the velocity and in the second case displacement at a given point. I hope that helps. Question number 5 here is, the instantaneous velocity of an object is v of t equals to 5 pi sine pi by 2t, where t is greater than or equal to 0. Its initial position is 10 centimeters to the left of origin. Find position of the object at t equals to n, where n belongs to integers from 0 to 5, both included. Display the position of the object in the first 5 seconds, right? So we are given the velocity, which is equal to 5 pi sine of pi by 2t, right? Now we need to display the position vector, so we want s of t, right? So s of t is integral of vt or dt, correct, with respect to time. So let's integrate this with respect to time, right, to get the displacement. So the integral of this is 5 pi is a constant, right? Integral of sine is cosine with a negative sign. So cos pi by 2t, so negative sign divided by pi by 2, right? Plus a constant c. So we can write s of t as equal to, so pi and pi cancel, this goes up, so we get minus 10 cos of pi by 2t plus c. Now it says its initial position is 10 centimeter to the left of origin. So that really means at t equals to 0, s of t is 10 centimeters to the left is equals to minus 10, correct? So we'll substitute this value. So we get minus 10 equals to minus 10 cos of 0, right? Plus c. Now cos of 0 is 1, and so we get c equals to, well, minus 10 plus 10 is c, which is 0. So we can write down the function displacement is minus 10 cos of pi by 2t, c is 0, right? So that becomes our expression for displacement. Now let us find the values which are required. Find the position of the object at t equals to n, where n is from 0 to 5. So it's better to make a table and then we can write down the values, right? So for different values of n, which are 0, 1, 2, 3, 4, and 5, let's calculate this value, which is s of t. So if I write 0 here, cos of 0 is 1, so we get minus 10. If I write 1, cos of pi by 2 is 0, so we get 0. If I write 2 here, we get cos of pi. So, those of you who find it difficult, what we could do here is that we could actually sketch the cosine function, right? So let me do that. So cos function is kind of like this. Do you see that? So that is the cos function. Now when I say 0, so at 0 it is 1. This is the value 1. When I say 1, we are talking about pi by 2, and this is pi by 2. Correct? Pi by 2 is 0. So when I write 2 here, I get cos pi, and cos pi is minus 1. So minus 1 means minus and minus becomes plus 10. Do you see that? Now at 3, we are now at this point, which is also 0. So we get this as 0. And at 4, we are at, this goes 2 pi. So at 2 pi, it is 1. So we get minus 10, right? And then again, it will go further down, right? So next point here is this one, which is 0. So we come back to 0. Okay. So these are the values which you get for displacement. Now, we need to display this. So we got the values. That's the part 2. Now in part 3, display the position of the object in first 5 seconds. So you can see that it moves from minus 10 to 0 to 10 like this, right? So to display, or we could do like this, right? So let us say that this is our 0 here. Now since this is 0, we are beginning from minus 10, right? So it starts from minus 10. Let's say this is minus 10 here, right? And let's say this is plus 10 for us. So at 2, it is plus 10. So it begins here, it goes up to this point and then turns. And then comes back to minus 10 and then goes to this point and then stops. I mean, it just moves on, but we are only interested in this cycle. So that is what is happening. And these turning points are at t equals to 2 and this one is at t equals to 4, correct? So that becomes the displacement, right? S of t, let me write S of t here, with time, correct? So that is how you could show your graph. So I hope the concept is absolutely clear. Question number 6 here is from a test paper. The question is, two particles moving in the same straight line start at the fixed point O. Their instantaneous velocity in meters per second is v1t is 6t minus 8 and v2t is 4t at time t. Determine their velocities when their positions are the same. You can always pause the video, answer the question, and then look into my suggestions. So we need to first figure out when will their position be same, and at that time we need to find the velocities, correct? So determine their velocities when their positions are same. So as you know, position is basically integral of velocity, right? That is what position is. So in our case, we are given the velocity, so we can say the position of the first, there are two particles, so first one will be integral of the first velocity. So in our case, first one is 6t minus 8 dt, right? So that gives you 6t square over 2 minus 8t, or is equal to 3t square minus 8t. I should write plus c also here, right? Plus c, right? So that is the first one. Second particle, the velocity is integral of the velocity which is given to us as 4t. So it is 4t dt, right? So that should be equal to 4t square by 2 plus another constant c, right? So that is how we could relate. Now it also says that their instantaneous velocity, the two particles moving in the same straight line starting at a fixed point O. So their starting is at fixed point O. O is the origin for us, right? So at t equals to 0, S of 0 at t equals to 0 is 0, right? That is what it is. So if you put that condition in these, so that is to say, at t equals to 0, S is equals to 0, right? So, and they are starting from the same position, right? So both should be same position. So that gives you that in the first case, S of 0 should be equal to what? We are writing this as 3 times 0 square minus 8 times 0 plus c. So that gives the value of c as equals to 0. And in the second case also, it is 4 times 0 square over 2 plus c. So that also gives you c equals to 0, right? So clearly we have our displacement for the first particle. The displacement is 3t square minus 8t, and for the second it is 4 divided by 2 is 2, so we can write this as 2t square, right? So that is 2t square. Okay, so we get these two displacement functions. Now is determine their velocities when their positions are same. That means we need to now figure out what is the time when S1 is equal to S2, right? So we need to find the time when S1 is equal to S2. So let's equate these two. So we get here 3t square minus 8t equals to 2t square, right? So bringing it to the left, we get 3t square minus 2t square, right? So minus 8t equals to 0, right? So that means t square minus 8t equals to 0, right? So that cancels away. Now you can take t common. So if you take t common, we get t minus 8 equals to 0. Now this equation is true for t equals to 0 and also for t equals to 8. Now we have already considered 0, right? Now it says determine their velocities when their positions are the same. So now the question is not very clear. Is it at the starting point? Because there are not two positions. So what we will do here is that we'll calculate the velocities at both the times, right? We know the velocity functions for v1 and v2. So let's calculate both velocities at t equals to 0 as well as t equals to 2, right? So for v1 at 0, we get what? So if I substitute 0 here, we get minus 8 meters per second. And at 8, v1 at 8, we get 8 times 6 minus 8, which is equal to, let me push this page slightly on the left side. So 6, 8, 48 minus 8 is 40 meters per second, correct? So that is for the first particle. And for the second particle, which is 4t, we have v2 at 0 equals to 4 times 0, which is equals to 0 meters per second. And at 8, it is 4 times 8, which is 32 meters per second. Is that clear to you? So that is how we can find both the answers, correct? So we'll actually, to be on safe side, work out at 0 as well as at 8, right? So these are the two times when the times when the displacement is same. Perfect. So that is how we are going to answer this. I hope the steps are absolutely clear. Here is a test question based on displacement, velocity, and acceleration. Question number 7. An object moves along a straight line with its position measured relative to a fixed point O. Its acceleration at any time t is a of t equals to 6t. So we are given the acceleration as equal to 6t, where t is greater than equal to 0. Its initial velocity is minus 25. So at t equals to 0, velocity is equals to minus 25, right? And at t equals to 1 seconds, its position is 24. And at t equals to 1, displacement s is 24 meters left. So it is minus 24, right? So it is written 24 meters left, so minus 24 of the reference point, which we are taking as origin. Determine when the object is located to the left of the reference point, right? So this is to the left of the reference point. Okay. So let's try to work it out. So we'll first find, we are interested in displacement position vector on the left. So we'll have to do integral of acceleration to find velocity first, right? Which is integral of acceleration. So that is 6t dt, correct? So which is 6t square over 2 plus initial velocity v0. Now at t equals to 0, we are given velocity is minus 25. So v0 is given to us as minus 25. So we could write this as 3t square minus 25. Is that clear to you? So we get the velocity function, correct? Now let's find the displacement. So displacement will be integral of velocity, right? So that is integral of all this, 3t square minus 25 dt, right? So that is 3t cube divided by 3, so they will cancel, okay, minus 25t plus initial displacement. Now we are given that the initial displacement is minus 24 for t equals to 1. So substitute 1 here and we'll write minus 24. Substituting 1 will give us 1 minus 25 plus initial displacement, and this is also minus 24. So we get this value as 0, right? So from here we can write down the displacement. So we get displacement as equal to, as initial is 0, so we get TQ minus 25T. Now the question is, determine when the object is located to the left of reference point. Okay, so we can factor this, right? So taking T common, we get T square minus 25. This is difference of squares. We can write this as T plus 5 times T minus 5, correct? So that becomes your displacement. Now, easy method here is to sketch the graph, right? So, zeros are at plus minus 5 and zeros, the right side is up, so it goes to, since this is positive, right? So, we have a 0 at minus 5, we have a 0 at 0, and we have a 0 at 5, correct? Now, let me just sketch it, and then we'll talk about it. So, right side up. Perfect. So we have so the graph is like this. So what we notice here is that if I have a value of t, we have to consider t greater than or equal to 0 only. So basically I should not be considering this half. So we'll only consider on this side, correct? So the question here is, determine when the object is located to the left of reference point, right? So since that is the displacement, and displacement is negative in this portion, do you see that? So it is on the left of the reference point when the time is between 0 and 5, correct? So at this time it is on the left, right, of the reference point. Does make sense to you, right? So you could do like this, or you could also test the intervals, right? And this gives you an idea that at 1 it is to the left, right? That minus 24 indicates that at 1 it is definitely to the left, right? And it works well with the graph shown here. So I hope that helps. So some of you can also test the intervals between 0 to 5, and then from 5 to a greater number. So if I substitute a value which is less than 5, which in this case at 1 we know it is negative, right? And here it is positive. So if I write a value which is, let's say 6 here, then all the 3 terms are positive. So when you multiply them, you get positive result, right? So displacement is positive. So that is how we are going to answer this particular question, right? So our solution is that the object is located to the left of the reference point when t is greater than 0 and is less than 5, correct? So it crosses the reference point at t equals to 5, perfect? Seconds. So these are in seconds, right? Okay. So I hope that helped. In this particular case, there was no need to sketch this portion. I should not have been sketching since we are given t is greater than or equal to 0, right? So we'll only sketch this side of the graph. Is that clear to you, right? And from 0 to 5, we see it is on the left side of the origin, right? Don't take this as the origin. This is where time is this. The displacement is negative for less than 5. So I hope that is absolutely clear. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.